In this problem, we're asked to work on the composition of two functions. Part A is a little bit of a warm-up problem, so let's start with that one. We're asked to compute f composed with g, evaluated at 1. The very first thing we should do is translate that to be f of g of 1. So we can see the order in which we need to evaluate these functions. 1 first goes into g, so we evaluate g when x equals 1, so 2 divided by 1, so 2. And now 2 gets plugged in for x into the function f. So 1 over 2 minus 4, so 1 over negative 2. Part B asks us to do nearly the same thing, but with an x instead of a 1. So here we have g of f of x. F of x is defined by the function x minus 4. And now wherever we see an x in our definition for g, we're going to replace it with 1 over x minus 4. So we have 2 divided by 1 over x minus 4. Because you can think of g as being a machine. Given the input, it takes that input and divides it into 2. So if the input is 1 over x minus 4, it's going to divide that into 2. And now dividing by this fraction is the same as multiplying by its reciprocal. So we get 2 times x minus 4 is the composition of g with f. Part C asks us to determine the domain of this new composition function. And if we just look at the ending result, that function has a domain of all real numbers. However, this result is coming from the composition of two prior functions which have restricted domains. In fact, we can see right here that we need to require that x not equal 4. So this composition would not be defined if x equals 4, negative 4. So in interval notation, we'd write that as being everything up to 4, union 4 to infinity.